So hello and good evening to Dr. Luan. So now I will be recording for the convergent test analysis. So maybe we change this name for the convergent test. So actually I've already created a Python model using the Solver software. And then I have insert the import the CAD drawing into the NC software which on here. And then now maybe we just checking for the unit, kilogram, mm, and then we checking for the analysis. So the 3D analysis, because this is a 3D model, so I'm making a 3D analysis. So now open for the analysis interface. Oh, we need to wait for a while because it takes some time. Yeah, so this is the model. So you can see this actually as a pipe clamp model, which this clamp will be used for clamping for the pipe. So the material that I will use is just using the structural steel. And the material property is actually being assigned inside the axis by its own. So I just simply make a simple geometry first, simple machine first. So we see for the machines. You can see the machine there. Actually for this, it's very large, so maybe we can make some amendments. So we make a sizings, which will select for the whole body. So maybe size usually to be 2 millimeters. And then make it refinements. So for refinement, maybe we make on here, make for the fillets, make for the pipe, fillet, fillet, and also for the circle. So remember when we clicking for this, we need to hold the control key. So you can see this is our geometry. Then now I update the machines. So now the machine is looking quite good only for here for corners because actually here is not very limitation place so we just leave there and then now it's 9,000 only so we really change after this we make analysis first. So we apply a force and down there we then the force for the pipe force, the force from the pipe. Then we make it to be component, maybe you just apply a 500 newtons for this acting outwards. And then we make a fixed supports. This is the hole for the fastener, so we make a fixed support here. Then we make analysis. Make a total deformation analysis. We make a stress analysis. So we want to make a convergence, so we insert convergence inside the total deformation. So for convergence, maybe we make it to be 5%, 1% first. So for it. You can see now the green bar is going on, so we will just wait for the result. So you can see the deformation is like around 0.4 millimeters, which is on the top, which makes sense because it's where the pipe force will be acting on. And so it will cause the deformations. And then from the equivalent stress, you can see actually it's at the fixed support there, which the fixed support is actually which we apply the forces to make to have and so we can see actually it's here. So because this is used to balance the forces of the pipe. So where we have a higher forces now, which like 1975.5 million Pascal, which is quite high. So maybe for the force that for this clamp is less design. We need to have a better design if we want to have a large want to clamp for larger force like 500 newtons, we need to have a better design, have a better thickness. But never mind, really just a simple test. So for here, you can see it's 0.6%, which is 1, 2, 3, 6, 4, 11. So maybe we change to these elements. So we change only to this, maybe we change to the one per part. Big. So now the element size is 15811, which is more than just now. This one, this is okay, never mind. This one is 1511112 something. So now we solve for the result. So we see that are they less than 1%? Less than 1% is very acceptable already. 15 now our element is 15811. So we see this the iteration look first. We already look one time, so maybe we just make it later we negatively look several times. 0.8%, so maybe negative look sometimes. Check. Maybe we change this to 0.5%. And same. Oh, 15811. So after we doing this, we can see that we want to achieve a 0.5%, we need to have a 62,000 elements. But you can see, you can analyze on this. So 0.418, 0.419. But this is actually double of it. So in order to get a 0.001%, 0.01 of the deformations. So it will have a double elements, which mean that the computational time may be double of it. So maybe we just go for this 32,001. So maybe we change now it's 15, so maybe we double of it. We make it to be 1.5, so maybe we make it to be 1.1 and then generate generate this update. Then never mind. Should be fine. So now it's 36,000. So when you achieve this, then we solve, see the result. Convergent time is one, we want to find the optimize that give us the better solutions, the best solutions in order to save our time because 0.001 mm is actually is relatively small, which when we designing materials, we will have a design factors. So this design factor is actually covering on this 0.001 mm. So that means the result actually is quite good already. So you can see 0.002 mm difference, but actually it's double of it. So we can say that in this result, we can conclude that our result for 36991 elements actually is the optimized result for getting this convergent test. So we will just going for these elements just for saving the time, for saving the resources and all of the resources up. So we also can see just like 0.001, 0.002 mm difference only. So like 0.5%. So it's not much different lah. So I think that's all for my convergent test. And then thank you.